everyone. I'm really excited to talk to you guys about this very exciting topic, which I think really bridges together the two tracks of this conference, education and technology. So my name is Soraya Beheshti, and I'll just give you a quick introduction about myself. I grew up in the UAE. I was born here, originally half Iranian, half New Zealander. I attended quite a lot of schools growing up, moved around a lot. And so, I've been blessed to be able to experience a lot of different kinds of education experiences. I actually went to Columbia University and was a student of the institution I now work for, Crimson Education. Crimson supports students in getting into top universities. None of my parents had gone to uni, so I wasn't really sure how to navigate that process. And found the experience immensely valuable, decided to bring Crimson to this part of the world. I felt like there was a need there. But I also founded a fintech nonprofit startup in university, which won a few awards and was nominated for a few awards that you can see there, and established Crimson in the MENA region. I now look after Crimson's growth in the Middle East, Africa, India, and Turkey. So today we're talking about lifelong learning in the age of machines. Our mission at Crimson is to be the launching pad that equips students around the world to compete on the world stage. We use technology to remove barriers of geography and legacy, and part of the way that we help students, get into their dream careers or universities is through this very, very personalized approach that's holistic and looks at, tutoring, technical skills, coaching, mentoring, leadership, and so on. So with that, sorry, there's a little bit of a delay here. And you can see that we've got some quite impressive results for the work that we do. But my session today isn't going to be about that. We're talking about lifelong learning. Sorry. So I want you guys to have a go. Oh, I see. Sorry, there's a little bit of a formatting issue, but I want you guys to have a go at memorizing this number. Can you memorize this number in 10 seconds? Anyone think you can? Raise your hand. Is it possible? Yes? Who thinks it's impossible for a human to memorize this number in 10 seconds? Human memory is complex, and it's comprised of a variety of functions, from working memory to long-term memory. This complex system is charged by the concept of scarcity, and here lies a fundamental difference between AI and humans. We have very limited resources and computational power, so our brains really want to make the most of the information that it receives. We are general-purpose learners. In order to optimize efficiency, working memory, which is just one component of the human memory system, condenses fragments of memory from our long-term memory bank that we can recall when faced with new information to assist in making a decision or calculation or completing a task. A computer can simply memorize this number, a number with even 1,000 digits, instantly. Now, reproducing this number series is beyond human working memory capacity, unless you know these two important dates of French history. So, July 14th, 1789, and January 21st, 1793. This was Bastille Day and the day that Louis XVI was executed. Individuals who have stored both dates can retrieve them from long-term memory. This process involves retrieving data from one context and applying it to something that's completely unrelated. And in that way, we can memorize. The ability to play with information, to use high-level thinking skills to control and direct less conscious levels of cognitive functioning is called executive function, and it's something that we are uniquely adept at. As far as we know, the genetic foundations of the human brain have not changed fundamentally in the last 50,000 years. However, as a result of our cognitive potential, the world around us has changed enormously. We have invented this incredible numinous system of representing thought and communicating thought, first through verbal sounds, which are quite random and funny if you think about it, and then again through pictorial symbols. This is language. This is our invention. We have invented institutions for facilitating cooperation and regulating competition, mathematics, time, our concept of time, even money. These are all metaphysical tools that we have invented to aid us in adapting to the world in which we exist. All living beings are born into a world in which they must accomplish fixed tasks, like getting food and mating and avoiding threats. This helps us to survive as both a species and individuals. You can think of instincts as built-in instruction manuals that enable us to be newborn into the world and still present with the unconscious or unconditioned knowledge that will allow us to survive in the environment to which our species is adapted. However, humans are a species on the move. Our environments have always been variable, and thus human brains needed to have some flexibility. That's why we're general purpose learners. This allows us to adapt to new stimuli and new conditions of living, and it's one way that our brains are quite unique. Human beings constantly react and adapt to their environment by learning through conditioning, frequently unconsciously. However, there's more to human learning than conditioning, and which, to the best of our knowledge, again, makes us different from other species and from artificial intelligence as well. Now, all living beings must learn how to communicate and generally survive, and some of this is innate, and some of this is taught. I'm going to share with you an experience I had when I was studying in the Atlantic rainforest in Brazil. It's pretty sad. I visited a rehabilitation center where birds like parrots and parakeets who were rescued from poachers or who were returned from captivity had to be retaught how to communicate as birds. Many of them had learned English or Portuguese words. They could say hello, they could ask how you are, but they had forgotten their innate bird song or their learned bird song. And that restricted their ability to survive in the rainforest. Because if you couldn't sing like the other birds of your species, you couldn't attract a partner, you couldn't exist in a social environment, and for social species like ourselves and like these birds, loneliness meant death. So it was pretty sad. I also saw the birthing nest of a harpy eagle, which is a highly endangered species of eagle. We were the first 12 people in the world to see it. Now, harpy eaglets are really interesting because they stay with their parents for 9 to 10 months learning how to survive. Their mothers teach them how to hunt, how to eat, how to fly. But these mother eagles are passing down information that really hasn't changed much since the dawn of the species itself. All living beings learn how to obtain food, but only humans have learned how to cook. We've continuously updated technologies to store and conserve food. We're not the fastest or strongest animals by any stretch, but we've invented cars, planes, and construction tools to enhance our own capabilities. Within 1,000 years, we've gone from inventing stone hunting tools to inventing the wheel, bikes, cars, telephones, cameras, the internet, even the metaverse. This is a testament to the unique mental flexibility of human beings. As I mentioned before, we're genetically equipped to survive the world as it existed around 48,000 BC. So we've talked about what's amazing about human cognition. What are some of the ways that we're not so hot? Well, compared with AI, we aren't very effective at all at processing data. We are much better at making abstract decisions. In the time that it takes a human to identify and label an image, an AI can classify perhaps 1 million of them. The sheer processing speed of computers enable them to outpace humans in any task that involves mathematical calculations and data processing. However, we're really good at continuous learning. When we learn something new, let's say you learn French, that doesn't override your knowledge of English, right? We have this amazing ability to integrate new information with previously learned patterns, meaning that over time, we build up this great wealth of experience and wisdom that allows us to deal with even more or ever more complex and unfamiliar situations. That's why we tend to think of people who are older than us as having a lot of wisdom. It's built up. For instance, if I was to give you a virtual reality headset and to put you into a VR game, you don't need to understand anything about virtual reality. You don't even need to know anything about the game to understand or intuit some basic rules. You should know that you probably shouldn't go towards fire. Don't jump over a mountain ledge. Avoid getting hit by vehicles. And a gun pointed towards you is probably not a good thing in this game. So that is you applying information that you've learned in another context to this new context. For AI, every new game is a new unknown world that it must learn from scratch or have rules programmed into it. Human intelligence shines in situations where you need to make decisions with abstract contexts or unfamiliar problems. So we can use common sense and executive functioning, and while it won't always be the best decision, it's something that we definitely can do. And this is why top MBA programs or other postgraduate programs equally focus on things like situational judgment, relationship building, and soft skills, as they do, if not more, than on some of the more technical skills that you might need to know in business. So, there are two ways in which we learn. The first is directed learning. This is a simple method of providing exact step-by-step instructions to perform a given task. There's no scope for deviation with directed learning. Think of workers on an assembly line who master a specific fixed task. They know where it's coming from, what material they're working with, and what they have to turn it into. This is quite different to an engineer in a lab who, is given a problem and has to figure out how to make B from A with no instructions provided. Directed learning is how most classic computer programs work. A program is a sequence of steps that a computer executes as designed by a human programmer. Crashes occur when the computer has no intelligence to deal with unknown issues. Early AI programs sometimes dealt with these kinds of problems, or they could deal with problems, but only problems where the programmer had laid out an if this, then function. The AI itself was not capable of drawing its own conclusions. Of course, this can change. Now, assisted learning, this is how good teachers teach students. The focus of teaching is not just to learn the exact subject matter, but also to gain general understanding. Providing many examples of a problem helps a student understand data patterns. With enough practice, the student develops a mental algorithm to deal with similar situations. This is how IBM's Watson works. To help Watson become an expert at diagnosing cancer, it is fed with millions of detailed records of cancer cases, their symptoms, their treatments, and outcomes. Watson is also fed with a lot of research papers on oncology. Watson can then analyze these patterns to provide assistance or suggestions to doctors, who are, at this point, still very much crucial because human doctors can make use of that wonderful cross-disciplinary, integrated knowledge to be able to filter through and complexify some of Watson's predictions or suggestions. Google uses a similar technique for automatic translation. Machine learning enables reliable lip reading by feeding them with millions of samples of people talking and the corresponding text. And thanks to this technique, machines are able to recognize and understand subtle patterns in images, sounds, and body language much better than humans, and much more thoroughly. Same with Amazon's product recommendations or Facebook's face recognition. So how machines learn. Artificial intelligence is very good at processing data, bad at thinking in the abstract. Very few humans have, photographic memory. For a computer, memorizing a book is as simple as pressing save or copying the file. Likewise, unmemorizing is pretty hard for us. How many of us would like to delete embarrassing memories? We can't, but computers can. However, AI falls short in applying common sense or transferring knowledge from one area to another, especially where that is not pre-coded. So if you want to be prepared for the AI-powered future, one of the best skills to focus on is management. Management and everything that we think of management and leadership to entail today. So that's kind of your agile thinking, your relational skills, emotional intelligence. This is where we really do shine. The ability to progressively learn by accommodating new knowledge while retaining previously learned experiences is referred to as continual or lifelong learning. Lifelong learning is one of the most challenging problems in machine learning, and it remains a significant hurdle in the quest for artificial general intelligence. When AI systems learn new strategies, this learning often overrides previous knowledge. In contrast to the way humans integrate new knowledge to the repository of previously accumulated information. Different tasks might require different data, or they might process the same data in different ways. And this is rather dramatically referred to in computer science as catastrophic forgetting. For current AI systems, new learning leads to abrupt decreases in the performance of previously acquired knowledge. Human performance, on the other hand, actually increases when we layer different ways of knowing, when we integrate different perspectives of truth. And this is why companies and universities are so interested in actively seeking out diversity. You know, there's an ongoing debate today about equal opportunity. And I think universities generally on the whole are very, very defensive of this, not only because it's the right thing to do, but because it's really good for you as a private institution to foster a diverse environment where new perspectives are colliding with each other and leading to more and more innovation. The kind of human jobs that will be phased out in the AI-powered future are jobs that require mechanical tasks, mathematical computation, and predictable execution. To thrive in the AI-powered world, humans should take advantage of our unique value, the ability to problem solve, to continuously build on knowledge, and integrate contradictory thought into complex and richly multifaceted models of the world. In our ever-evolving world, it's absolutely critical to be a lifelong learner. To those who are able to transfer knowledge from one domain to another, build on it, add to it, and continuously update it, will fare best in the age of machines. Every industry has embraced the digital revolution to become more efficient, sustainable, and accessible. This means that the employment landscape is constantly changing. There are new jobs that are arising at a faster rate than ever before that simply didn't exist a few years ago. I've heard some of the conversations that a lot of you guys have been having with each other about new technologies and blockchain and cryptocurrencies. There are evolving career opportunities that call for refreshed and sometimes entirely rebuilt skill sets. With few exceptions, employers no longer seek employees that can master one task repetitively and do it for 20 years. Rather, shifting career paths, adding new skills to your repertoire are perhaps a more attractive quality in a candidate than mastery of one single task. And like I say, there are some few exceptions. When progressing in your career, it's important to demonstrate a commitment to lifelong growth and learning agility. This is one of the reasons why I'm going to share that soon. One of the reasons why top US universities follow a liberal arts curriculum, which means that regardless of whether you're studying engineering or linguistics, you're going to do a kind of common core, that's what it was called at Columbia, that involves quantitative subjects, language, humanities, literature, and so on. The idea is that providing you with depth as well as breadth will enable you to thrive into the world that you graduate into. And I wanted to share this story. This is from our Slack channel. We were working with a student, helping him prepare for university, and he also was doing a research project through Crimson Research Institute, which is our research division. He was working with a professor for his own research. He's in 9th grade, so quite young, and his dad was so excited at what the son was doing that he decided he wanted to apply for his own postgrad programs, and he ended up getting into programs at Dartmouth and Columbia. So this is, one example of that dedication to lifelong learning, which in this case is, really a family value. It's critical to keep your skills, and achievements polished. Letting a professional development wane can be the reason, can be the reason why a colleague gets promoted or a fresher, sharper candidate gets the role you wanted. Whether applying to a new company or trying to progress in your current one, it's important to show ambition and dedication. And one of the best signals of dedication to career development can be continuing education, whether that's formally or informally. Learning new skills adds value to the skills that you already have and allows you to pivot to fill the needs of a constantly growing and changing workforce. The more skills you have, the more you bring to the table. So the key here is to see that continuous learning, again, that uniquely human ability as, a kind of protective mechanism against knowledge becoming obsolete, especially since AI are able to learn a lot of the more mechanical tasks much more quickly and catch up to us in a way that we can't really compete with. All right, sorry. Whether you're 16 years old or 60 years old, Crimson wants to help you. We want to help you develop your own personalized learning roadmap. So if any of you are interested in what that could look like to you, do find me or my colleague Madhav over there, and we'll be happy to chat with you. So we use a digital-first learning environment, and we build our own technology to maximize engagement. In addition to our consulting, we also have a school, which is what we think is the education system of the 22nd century. We're trying to teach students those agile skills, learning agility, growth mindset, as well as things that we think should be important, like leadership, entrepreneurship, investments, 3D game design, to enable them to thrive in the AI-powered world. And we've been joined in our mission by some faces that many of you will probably recognize, especially in the education and technology spaces. People like Larry Summers, former advisor to President Obama and former head of the World Bank, Julian Robertson from Tiger Global, and of course, Kevin Rudd and Sir John Key, the Prime Ministers of Australia and New Zealand, New Zealand being where our company was founded. So I'm really excited about that, and I really, really thank you. I can't believe I finished this with 6 minutes to spare. Thank you guys so much. If anyone has any questions, I'm happy to answer them, but if not, you can come and find us. We'll be here today and tomorrow.
No? Ah, yes, there it is. Thank you very much. That was really enlightening. Does anyone have a question for Soraya?
No?
Yes.
Hi, I'm Bert. It was really inspiring, your talk. I just was wondering, are there any basic skills you need to work with AI? I mean, because you talked about all the soft skills you need and it will become more and more important, I believe it. But what about literacy, for instance, knowing how to read, knowing how to understand how AI works, for instance, the patterns? How do you look at that?
Oh, you mean like if you're actually wanting to work with the AI?
Yes.
Yeah, I mean, so for that, you definitely want to develop tech literacy by doing some kind of formal study in it. I mean, you can do it informally too, but it's going to be hard, especially if you want to start working with hardware. So I would recommend, really looking into some university programs like postgraduate programs that would kind of give you a really in-depth knowledge. The challenge, though, is that with really emerging technologies, sometimes the technology develops too fast. And I remember at Columbia, I was on the blockchain club, and we were trying to, we had a blockchain club, and we were trying to get a course approved, but the bureaucracy, just to get the course approved, would take so long that by the time they issued an approval, whatever was in the curriculum was already a little bit obsolete. So then, for kind of really specific skills that might be challenging to learn in that kind of environment, you could look at kind of specific institutions. So you have Code Academy, for instance, which gives really good practical online learning. We also have something called Crimson Code, which are like sprints. So these would be 3-month courses in things like artificial intelligence, web development, app development, data science that are practical. And these are actually for young students as well. High school students. And then I also think that there's huge value in experiential or project-based learning. So
okay.
Even if if that's not someone's career field, then maybe, and you want to explore a new career path, then even joining sort of fellowship programs or internship programs to learn about those new technologies and be able to apply new learnings on the job is really advisable. But it depends on what the purpose of
yes,
it
and
is.
do you think everyone needs to have some understanding? Should it be in the general curriculum of everyone to at least understand how it functions, or won't it be needed? Is it just, yeah?
I mean, for now, probably not, right? But so we're always encouraging it for students because definitely by the time they finish university, if you want to be a doctor, you should probably learn robotics because there will be surgical robotics will be a huge part of medicine by the time they graduate in 100 years. Okay. Or even applications which we think are safely in the human domain are also getting competitive with AI. So I know that there was a study recently that found that AI could perform some aspects of law better than humans. So maybe not argumentative aspects like as a barrister, but definitely the AI were in the solicitation part were much more effective and made much fewer mistakes in the legal profession or in specific tasks, very specific tasks. And my colleague Madhav today was telling me about how there have been some AIs that have actually beaten human debate champions in debate. I don't know the details of that. I'm not confident to share more on that, but that was pretty interesting to me. So right now, I'd say it's not essential, very good though, to have that understanding, but definitely in a few years it will be absolutely essential, even if it's just a basic sort of understanding of the language and the vernacular.
Anyone else have a question?
Yeah, thanks. So you just mentioned about universities and various programs having a lot of bureaucracies. And we all know that we have been talking about get good education, get good grades, get good job, all those aspects. Now, considering that scenario and when the good education is actually limited to, not more than 10% of the population, especially in developing countries, how do you see emergence of new organizations or platforms which may not be university affiliated but providing a really industry ready programs and developing them more holistically using various set of technologies like artificial intelligence or robotics, be it any professional, doctor or an engineer or for that matter a lawyer. So
Yeah.
what do you see emergence of those kind of platforms, and how would we will be able to come out of those university focused degree programs?
So I think that there are some really, really great vocational focused programs, and they're definitely the right choice for some people. However, I think that, so my interest in, for instance, the liberal arts system that I mentioned before is that it's the I think there's a huge benefit to a cross-disciplinary and multifaceted education as well. Like, if you want to study law, you can study law, but one of the reasons why the US requires you to have a different bachelor's degree first is because you should be a lawyer who knows something else than law. So, maybe you want to be involved in sort of regulating technology, then having a computer science degree bachelor and then going to law school would be really useful. Or maybe you're interested in sort of like biotech law, then having a degree in biology is so useful. So those are two different schools of thinking. The UK system, for instance, is really much more focused. Like, you just go into law directly, you do your law subjects with other law students, and there's not a huge amount of flexibility there. So I think it also depends what your goals are, because like the value of an elite university education, let's say, is not really the things you're learning. Harvard knows that. That's why they don't mind to publish their courses for free online in Coursera. You could create a whole Ivy League degree just through the Coursera courses that the Ivy League universities post up there. So that's obviously not their value proposition, or they wouldn't give it away for free. What you go to an institution like that for is the collision rate with other really bright thinkers, the sort of ability to be taught by professors who are masters in their fields, and that whole network that you get afterwards. So obviously that's not accessible to everyone. That whole value is built into its exclusivity. And so I think that, democratizing education through, for instance, providing asynchronous learning or online learning is massive. I mean, there are some pretty amazing companies in India who are doing this, like schooling on a massive scale, really, really efficient delivery. It depends. Different schools of thought.
Yeah, so I am from India and I know how good things are happening there. The only challenge which we are finding out right now is acceptance of these non-university degrees or affiliations or education being recognized within the higher education, even in globally, as well as in the corporate sector when it comes to the jobs. Mm-hmm. So is it going to change? Are there changes coming in right now, or how is the industry evolving from that perspective?
There are, the really forward-thinking companies don't. I mean, Google, for instance, doesn't require you to have a university degree to work there as a software engineer. They just ask you for specific capabilities and they'll test you on it. So standardized testing can help with that. That being said, I think that there is still a huge, or many companies and individuals still see a huge value in the formal standardized education, because the difficulty with not having that is then comparing, candidates. Whereas we know that, for instance, if you graduated from Princeton in the past 5 years, you probably worked really super, super hard to get there. And that tells us a lot about your kind of resilience and your dedication, your ability to set goals and achieve them, even when they're immensely competitive. And that tells us a lot about your personality, I think.
Thank you. Thank you so much.
No problem. Thank you, guys. It was really fun.